Welcome back to another episode of Tooling Time. My name is Chris O'Keefe. I run the lab here at Allfill. For the past couple months, we've been working on moving into our new lab facility here at our sister company, Auger Fabrication in Downingtown. The new lab is about 4 times the size of the original lab. We've got all new equipment, new dust collection system, and we've made some massive improvements to the place. So we've been very, very busy, and that's why we've had to take a step back from our Tooling Time videos, but we're back at it today. And we're going to be discussing slow speed agitation with you and why it's absolutely crucial to the performance of your machine. This is our standard agitation blade that comes with probably 90% of our tooling. Inside the machine, I have one already mounted up inside there with a set of tooling. We've got a non-free flowing powder in here. It's a soy protein powder. And it's going to be good to just kind of demonstrate the benefits that a slow speed blade will have in getting your material to feed through the auger. So what we're going to show in this clip is the effects of not having a slow speed blade in the machine. I'm going to turn it off and run the machine to show the material and how it flows through, the signs that you'll notice in the material throughput and the sounds that it makes. And then we're going to go ahead and engage the agitation, do the same exact thing, and show you the improvement in the material flowing through the machine to really show you the benefit of having an agitation blade like this installed in the machine and set up properly. So step one, I'm going to go ahead and just run a couple cycles of material through this without the agitation turned on, and you'll be able to slowly hear the auger starve. That's the term that we use, and essentially it's going to start to sound hollow, a little more metallic, because the material no longer is wrapping around the auger and feeding efficiently. So the tooling is actually kind of wobbling within itself. So no more material is coming out. And you can hear that kind of metallic rattling noise. So essentially what's happened is this agitation blade is no longer spinning, which if you didn't install it in the machine, it wouldn't be spinning either. And what that's done is it's prevented the material in the hopper, on the outside edges of the hopper, it's prevented it from falling into the tooling, to the overflight of this non-free flow tooling. And that's the main benefit of this, is that it sweeps the outside edges of the hopper and it ensures that the material is falling down into the tooling so that the flighting is always filled efficiently every single cycle. So I'm going to go ahead and turn the slow speed agitator blade on, load this material back into the hopper. We're going to run a couple more cycles and you'll see it start to become efficient again, and you'll see the massive improvement that this slow speed blade has on the performance of the machine. So I'm just going to go ahead and set our agitation to with fill. There's another option in there called continuous. With fill agitation means that when the auger turns, the agitator blade turns. As soon as the auger shuts off, the agitator blade shuts off, unless you add a delay. Continuous agitation is when the agitator blade will sweep the hopper at all times, regardless of what the auger is doing. There's only a few occasions where you'll need something like this, a material that really needs a lot of agitation, or you're trying to maintain a consistency of the material in the hopper. The negative to continuous agitation is you will degrade your product over time if it's fragile. So let me go ahead and reload this. I've turned the agitation back on to with fill, which is our normal setting. Let me verify a few things. All right, so we're ready to run again. The first few cycles are going to sound hollow because, again, we haven't agitated any material into the auger, so the auger is currently just about empty. So as the agitation blade starts to sweep per cycle, you'll notice the material starts to flow out again and the sound changes, and it sounds really nice and smooth. That's what we're looking for. So you can see the instant improvement there with the agitation blade. The tooling's gotten quiet. The only thing to note, this material is just static prone, so you see it kind of fly away from the tooling. In a production setting, you could add a static eliminator bar or something along those lines. But for the sake of today's demonstration, you can see the massive improvement just from having the agitation blade shut off to turn on, and how quickly it starts to feed material through your tooling, and how you can actually hear the sound of the tooling performing more efficiently or less efficiently, depending on how you have it set up. So thanks again for tuning into another episode of Tooling Time. We hope this information was really helpful and informative for you. and that it helps you better run your own machinery if you have some. And if you're considering getting machinery, we hope it educates you on how this type of technology works. We're looking forward to having you back for another episode here in the future. We're going to discuss more types of agitation, different types of tooling, and a whole bunch of useful little tips and tricks for running your machinery.